Very wonderful day, students. Welcome to Edu-ca-te. Let us look at this problem that says find all the stationary points and classify them as local extremes or saddle points. I already made a video about the procedure. So basically, we are going to get to the process. Remember that the stationary points are those points where the gradient is 0 or where the gradient does not exist. So we need to know, are the points local minima or local maxima, or are they saddle points? So basically we need to find the points first. Before we get anywhere, let us find those points. So to find those points, the stationary points, remember that you have to find the gradient of the function. You have to find the gradient of the function. So the gradient of the function, remember that it is the partial derivative of this function with respect to x plus the partial derivative of the very same function with respect to y, and then you put j here. So now if you differentiate this function with respect to x, you see that here you have got only this term has got x, which is x sin y. So differentiating this in terms of x, you are going to get sine y. So this is sine y I, and then this is plus. Now, if you differentiate, if you find the partial derivative in terms of y, this term is called y. If you differentiate it, you are going to get positive 1 plus. This is positive 1 plus. If you differentiate this one, it does have sine y indeed. So differentiating sine y, whereas y is the angle, you are going to get positive cos y. And there's an x out there. So this is x cos y. So this is j. So this is the gradient of the function. This is the gradient of the function. So now remember, to find the stationary points, we must equate the gradient to 0, because we know that at the stationary points, there is either a gradient of 0 or there is no gradient, or the gradient is undefined. So in this case here, sine y, which is the partial derivative in terms of x, we equate it to 0. And we also have got 1 plus x cos y. We also equate this to 0. So here I think we can solve here this one better. So sine y is equal to 3 is equal to 0. So basically, what must y be so that sine of that particular angle is 0? So we know that on the sine graph, it intersects at the origin. So basically, for this to happen, y must be equal to 0. So for us to have sine y is equal to 0, then y must be equal to 0. So we can just say we have got this point where y is equal to 0, and we can take and substitute it here. We can take it and substitute it here. And if we substitute it here, we're going to get 1 plus x cos of 0 radians is equal to 0. So now here, cos 0 is just a 1. So this would be 1 plus x is equal to 0. So x is equal to negative 1. So we have got a stationary point whereby I will name this point P, in which the x value is negative 1 and the y value is 0. Okay, so there might be arguments indeed that you can put another value for y to get 0. Maybe you can put 2 pi. Okay, you can put 2 pi, or you can put pi and all those. So y can be actually pi, or it can be 2 pi, or it can be 3 pi, and so forth. So actually y is actually an integer multiple of pi in a sense. So y is an integer multiple of pi. So here, if we put pi here though, if you do the cos of pi, you're gonna get 0. So basically this one won't work. The only solution that works is when y is equal to 0. Try it. Go ahead and take pi, which is 180 degrees. Go ahead and substitute it here. You are going to get cos of 180, which is going to give you negative 1. But okay, it's going to give you negative 1 this side, but this time this side is going to give you 0. Yeah, so basically I think that you're going to get only one x value, which is x is equals to negative 1. But let us just try here and say if y is equals to pi. If y is equals to pi, we know that sine of pi or sine of 180 degrees is 0. So if we substitute that into that equation, then we're going to add an x value that is 1 plus x cos of pi is equals to 0. So cos pi, which is cos of 180 degrees, will give us negative 19. Okay, negative 1, I mean. It will give us negative 1. So this will be 1 minus x is equals to 0, such that x is equals to positive 1. So yeah, we do have another point. We do have another stationary point. We can name it Q, given by an x value of positive 1 and a y value of pi. So an x value of positive 1 and a y value of pi. So if we continue doing this and putting 2 pi and whatnot, I think we'll end up getting the same outcome. Because if we are going to put 2 pi into this equation, of course 2 pi sine 2 pi will give us 0. So if you are going to put 2 pi in this where there is y here, you are going to get the same value as the one that we got here first. So we have got 2 stationary points. You can further prove this on your own. It's just that I wasn't ready to do that. So basically you can further prove this on your own by substituting 2 pi into here. I think you're going to get x is equals to negative 1. So the values will continue alternating. So these are the 2 stationary points that we have. Now we have to classify them as local extremes or as saddle points. Now we invite the second partial test, whereby we need to find the discriminant. But first of all, we need the value of a, we need the value of b, and we need the value of c. So we've got 3 things that we need: a, b, and c. Remember that our function g at xy was y plus. So our function gxy was given by y plus x sine y. So this is y plus x sine y. So y is equals to, okay, so this is our function. So remember, to do this second partial test, number 1 thing you have to do is to find the value of a. Okay, so the value of a, remember that it is the second partial derivative of the function with respect to x. So it means that you have to take this and find the partial derivative with respect to x. So partial derivative of this with respect to x, we already found it that it is actually positive sine y. So with respect to x, this is the partial derivative. So we are going to derive it again. We are going to actually do a second derivative with respect to x. So basically in this case, the value of a is the second derivative of the function with respect to x. You are just going to differentiate this with respect to x 2 times. In this case, if you differentiate sine y with respect to x, this is going to give you 0 because sine y does not contain x in it. So we treat it as a constant. And in this case, y is not a function of x. So this is not a single variable function. So basically here, the value of a will be 0, which will be the derivative of sine y in terms of x. Okay, then now the value of b, remember that it is given by the second partial of g over partial y partial x. So basically here, remember that when we were finding the partial derivative in terms of y, the first one, in terms of y, we just differentiated this 1 and we got 1 plus, and differentiated this one, we got x cos of y. Okay, x cos of y. So this is 1 plus x cos y. That's the same thing that we have gotten here as the partial derivative in terms of y. So we are going to take this partial derivative in terms of y, we are going to differentiate it with respect to x now. So that's the value of b. The value of b, always you take the partial derivative in terms of y, you are going to differentiate it in terms of x. So you look where there is x here. So this is where there is x. So where there is x, then we are just going to differentiate. And if we differentiate correctly there, we're supposed to get something like just cos pi, cos y. So the value of b is cos y. Because if we differentiate x here, this is just going to be 1. 1 times cos y will be just cos y. The derivative of 1 is 0. Since it's a constant, there is no x in it. And then now the value of c, it is the second partial derivative in terms of y. So basically, you are going to do the second derivative in terms of y. You are basically going to take the partial derivative in terms of y, and you're going to differentiate it again in terms of y. So if we do that, this is the partial derivative in terms of y, the first one, the one that we did at the beginning. Basically, we have got cos y in our equation. There's a cos y there. So if we differentiate cos y, we are going to get negative. We're going to get negative sine y. And there's an x there. So this will be negative x sine y. So you've got the values of a, the values of b, and the values of c. Now you find the discriminant. Remember that discriminant is given by AC's, okay, AC minus B squared. So it's AC minus B squared. In this case, the discriminant is A. The value of A is 0. So this will be just 0 minus. The value of B is cos y. So this will be cos y squared. So this is just cos squared y. So the discriminant is given by cos squared y. So you have found everything that is required. You have found first the stationary point, and now we have found the value of A, B, and C, and D as well, which is the discriminant. Now we want to do the partials test. So now doing the partial test, remember that we need to classify these stationary points that we have found. We need to see, are they local minimum, or are they local maximum, or are they saddle points? In this case, we have got point P given by -1:0, and we've got point Q given by 1:pi. So we have got point P given by -1:0, and we've got point Q given by 1:pi. So these are our 2 points. We have to find the what? We have to find the value of A and the value of D so that we can state our result. So that we can classify our point into being a local extreme point or being just a saddle point. So in this case, you can see that the value of A is just 0 here. It is not affected by this x value at all. And the value of D is given by cos squared y. In this case, the value of y is 0. So if you do D is equals to cos squared, you substitute y is equals to 0 here. Remember that cos of 0 is 1, so this is just going to be 1. So this is cos 0 squared, which is 1 squared, so the discriminant there is +1. So which result is this? You have got the discriminant is greater than 1, and the value of A, okay, the discriminant is greater than 1, and the value of A is equals to 0. Remember that if the discriminant is greater than A, okay, is greater than 0, and A is also greater than 0, this is a local minimum. If the discriminant is greater than 0 and A is less than 0, it's a local maximum. And if the discriminant is negative or the discriminant is less than 0, then it's a saddle point. But in this case, I'm not sure how to classify it. Yeah, you can comment in down below and tell me this result, because we have got A is equals to 0. A is neither negative, it is neither positive, but the discriminant is positive. Is this going to be a saddle point, a local minimum, or a local maximum? Let's go to point Q. So point Q, the value of A remains 0. Okay, but now to find the discriminant, the equation says cos squared y. So you have to do D is equals to cos squared. The y value there is pi. Remember that pi is going to be your, remember that pi, it is 180 degrees basically. So cos of 180 degrees is going to be -1. but there's a squared there, so -1 squared will just give you 1 as well. So the discriminant is also 1. So now I want people to comment down below. What is the result? Because we have done the test successfully. Is P a saddle point? Is the local minimum? Is the local maximum? Of course, it cannot be, both of them cannot be saddle points. So it's either local minimum, local maximum. They have the same discriminant. I'll leave this up for you as I do more research. Thank you for watching, ladies and gentlemen. Stay tuned for our upcoming videos.